Okay, ladies and gentlemen, I thought it might be appropriate to have a quick walkthrough of the study guide since I'm not able to be there in person with you. So, without any bells and whistles, here we go. First thing on the study guide talks about nuclear fusion. So, things you need to know. Nuclear fusion occurs in the core of the sun, or in the core of stars, which is the middle portion here. What happens is hydrogen combines with hydrogen, and it takes 4 of them, and they combine to produce helium. Okay, the reason they fuse during nuclear fusion is because they're moving really fast because it's really hot and there's a lot of pressure from the gravity of the sun. So when they fuse, they form helium, but they lose a little bit of mass. That mass gets converted into energy, and the sun gives off energy, mostly in the form of light and heat and UV rays. But there's a little bit of X-rays and a little bit of gamma rays and a little bit of radio waves and a little bit of microwaves. But it's mostly light, heat, and UV rays. So again, nuclear fusion's in the core of the sun. Tremendous heat and pressure causes them to fuse. When they fuse, they lose a little mass. That mass becomes energy in the form of light, heat, and UV rays. That is nuclear fusion in a nutshell. Second thing on your study guide talks about solar features and activity on the sun. So we'll start with the layers of the sun. Outermost layer, extending way out into space, is the corona. Corona literally means crown. That is the crown of the sun. It's the rays that extend outward. It's the not very dense gases and plasma extending out from the sun. Closer to the sun, I need a better color here. Let's use red. There's a really thin ring close to the sun's surface. The only time you can ever see it is during an eclipse, and that is called the chromosphere. It means color sphere. And last but not least is the sun's surface. The sun's surface is called the photosphere. Photo because it is visible. So on the photosphere, you can see spots. Bing! And they usually occur in pairs or in groups. That is because sunspots happen when the sun's magnetic field gets all twisted up. And again, the sun has numerous magnetic fields. As the magnetic fields get twisted up, sometimes they bend outward. And when they come out and then back in, they leave dark spots because they're not as hot as the rest of the sun's surface. These twisted magnetic fields also lead to what are called solar flares, which often happen nearby the sunspots. They don't have to, but they typically do. Solar flares are explosions that throw pieces of the sun out into space. Let's see, what else do we have? Solar wind. The solar wind is the positive and negatively charged particles coming off the sun. Just a quick reminder, the sun is made mostly of hydrogen and helium. Hydrogen and helium. So the sun itself is a plasma for the most part, which means the nuclei and the electrons are ripped apart and they're moving around. So the sun is mostly hydrogen and helium nuclei and electrons. So these particles that are moving so fast that fly off into space is called the solar wind. And again, the solar wind is pieces of the sun. It is hydrogen nuclei, which are protons. It is helium nuclei, which consist of 2 protons and 2 neutrons. And it is electrons. That's what the solar wind is. Because the sun is so hot, the particles move really fast. Some of them escape into space, and we call that the solar wind. Let's see, what else did I miss? Okay, the last thing in that section on your study guide is what pattern do you see? So here's the pattern that you see in the sun's activity. As you can see, it's a repeated pattern, and it repeats every roughly 11 years. What that means is when it hits the peak, which is called solar max, the sun is most active, you see lots of sunspots, there are lots of solar flares, and there's more intense solar wind. This pattern repeats itself every 11 years, roughly. Last but not least, well, basically, hang on, back up. Why does it repeat every 11 years? Basically, we're waiting for the sun's magnetic fields to get all twisted up. When they're really twisted, they're right here. When they snap and unravel, that's way down here. And then they get all twisted up again. So we don't know exactly why or how this happens, but that's what we can see taking place. Last but not least is the sun's impact on Earth. not in terms of sunlight and heat, we know what that impact is, but the solar wind particles, which again are hydrogen and helium, nuclei, and electrons, are flying through space. They affect our bodies like high doses of radiation would, which is not good. So we have a magnetic field that protects us. For the most part, as the particles hit the magnetic field, they go around, but occasionally you can see Earth has a positive end. Occasionally the electrons will get attracted and get pulled in. And occasionally the protons will get attracted and pulled in down here. Notice they enter at the North Pole and South Pole. That's because that's where our magnetic field enters and exits the Earth. As a result, those electrons and protons run into our atmosphere. When they run into the nitrogen and oxygen in our atmosphere, it energizes those atoms. When those atoms give back up that energy, they give it up in the form of light. So what you have is a transfer of energy from energy of motion, kinetic energy, to light energy. When we see that light energy near the North Pole and the South Pole, we call those auroras. And that is a quick, well, sort of quick overview of what's on your study guide and what to expect on your quiz next week. Good luck.